Hi and welcome to this module on recycling. Recycling is one of the three components of the resource recovery aspect, or RRR. This includes reduce, reuse, and recycle. Reduction is mainly achieved by policy interventions. As an example, we can mention the prohibition of plastic bags by the government of Zanzibar in 2011. Whereas reuse of waste is practiced every day all around the world, and it is easy to understand what it means. Here you see a picture of how electronic waste can be reused to make beautiful jewelry. Reduce and reuse are pretty straightforward terms. Consequently, this module will focus on recycling. We will see how four of the main municipal solid waste fractions are recycled. These are paper and cardboard, glass, plastics, and metal. We will see all this with real case examples from low and middle income countries. Let's start with paper. Paper and cardboard, which are produced from pulp derived from plant fibers, primarily wood, are used for many different products such as for packaging material, newsprint, and advertisement. Most of these products have very short lifetimes and thus constitute a major fraction of most waste. We distinguish three types of waste paper. Post-consumer paper, these are for example newspapers and magazines. Corrugated board, most of the times obtained from commerce. And high-grade paper, printing paper for instance, often coming from businesses. The paper recycling process involves several steps. Let's have a look to some Asian examples. The very first step is sorting and removing impurities. Waste paper has different prices depending on its color and thickness. These two women in Philippines are breaking books apart page by page and sorting them according to their color. The next step is repulping or grinding, which can be done mechanically, as shown in this plant of Kanpur in India, or chemically. Mechanical repulping yields lower quality paper than chemical repulping. After repulping, the paper is mixed with water to produce a slurry. This slurry is then thickened before being pressed. Bleaching, or whitening, is optional. After being pressed, the paper is dried and is then ready to be sold as sheets or rolled. Recycling of paper will never be able to close the loop fully. This is due to two reasons. First, paper mass is being lost by the storage of paper in archives, offices, in building materials, etc. And second, the shortening of fibers during repulping induces to a quality loss, in particular with respect to strength. To compensate, recycled paper should weigh 5 to 15% more per area or should be mixed with virgin pulp. Let's mention some interesting figures about paper production and trade in the world. Total world consumption of paper and paperboard in 2012 was around 400 million tons, to which Asia contributed 45%, almost half. Europe contributed 26% and North America 21%. But now, how much of all this amount is actually recycled? Hard to tell. It seems that the majority of the paper worldwide is landfilled. Although it is also true that recycled paper is an important part of the raw material used in the pulp and paper industry and is traded on a market that is global. Transboundary trade totals 40 to 50 million tons per year, around 10% of the total production. This trade is now dominated by the People's Republic of China, who imported a net quantity of 30 million tons in 2012. This is around 70% of all transboundary trade. Okay, but how beneficial is recycling paper for the environment? This table here shows us the inputs needed in terms of wood, for example, or water and electricity, and the residues and emissions generated in the production of 1 ton of newspaper. However, we compare how much it would cost to produce it from virgin materials and from recycled materials. And then the last column shows us the comparison. Here we see that actually the production from recycled materials is able to reduce wood consumption as well as water and electricity consumption. However, it increases considerably the energy consumption as well as the residues and emissions emitted. In any case, according to several life cycle assessment studies, recycling has a better environmental performance than landfilling and incineration of paper, especially when the logs not needed due to recycling continue in the natural cycle acting as carbon sinks. Finished with paper. Now, what is all about glass recycling? Glass is used for many purposes, but in the waste system, glass is predominantly found in terms of beverage and food containers. There are three types of glass. Soda lime glass is used for bottles, jars, drinking glasses, etc. It is produced in three different colors: clear, as in the picture, green, and brown. The second type is crystal glass, which is used for high-quality drinking glasses, vases, and art. And finally, we have borosilicate glass, also called Pyrex, which is used for laboratory glassware. This one is corrosion and temperature resistant. Only soda lime glass matters in waste due to its big amounts, and it is the only one that can be recycled by remelting. Should not be, of course, mixed with the other two glass fractions. Glass can either be reused, which would be ideal, or recycled in two different ways. Glass can be broken, and then this broken glass is called cullet, and it is remelted and used for the production of new bottles. But glass can also be used as substitute of other building materials, such as gravel and fillers. Let's have a closer look to a glass recycling plant in Manila, Philippines. First, the cullet is obtained from storage and it is manually separated and washed. Then, this broken glass is introduced in the furnace to be remelted. The melted glass is used for production of new bottles, which are later sold again. Cullet has the advantage that it prolongs furnace life as it melts at lower temperatures. As long as contaminants are removed, there is no quality loss of glass in the recycling process. Once colored cullet is mixed, however, the quality degrades. Compared to paper that we already saw, or plastic and metals that we will see later, the global market of glass is not so big. Virgin materials are abundant and accessible in most parts of the world at reasonable price. Here again we have a similar table comparing the production of glass from virgin materials and from recycled glass. We see the different amounts of inputs that are required and the different amounts of wastewater and emissions that are generated. The results show that actually recycling reduces most of these inputs and also the outputs in considerable amounts, meaning that recycling glass has environmental benefits. Let's now talk about plastics. Plastic is produced from fossil oil. As a curiosity, about 4% of the petroleum consumed worldwide each year is used to make plastic, and another 4% is used to power plastic manufacturing processes. Plastic is used for many different products, many of which have very short lifetimes and thus constitute a major fraction of waste. In plastic production, fossil oil is distilled to fractions containing a mixture of hydrocarbon chains. These are cracked into repeating molecular units called monomers. The monomers are synthesized into polymers, forming the base material, for example, granulate or powder. Based on their chemical difference, we distinguish different types of plastics, which are shown here with their names according to the Plastic Industry Trade Association. Plastic recycling presents two problems. On the first hand, it contains plenty of foreign items and contaminants, such as organic waste. On the second hand, different plastic types are often mixed together. When mixed plastics are recycled together, the material loses its cardinal feature, which is great strength and flexibility at small dimensions. In any case, plastic recovery can be divided into two overall classes: energy recovery and material recovery. Energy can be recovered in the form of heat and electricity. Material recovery can be done in two different ways: either chemical recycling, also called feedstock recycling, and mechanical recycling. Chemical recycling breaks down the plastic into its monomers, and then these monomers are used in refineries to produce new plastics. Whereas in mechanical recycling, we distinguish the following steps. The first step is sorting. These operators in Bangkok are sorting different plastic colors and types. Then, sometimes material needs to be prepared for transportation, and that requires compacting. This can be done with a truck, as shown in this movie from the Philippines. Once the material arrives to the installation, it needs to be washed in order to remove organic waste remains and impurities. The washed plastics are later dried. Once they're dried, the plastic is cut into chips. The chips are then ready for extrusion. When mixed colored chips of plastic are extruded, we obtain a black plastic as shown in the movie. This finalized plastic is then ready to be palletized. Some global facts. The plastic global production in 2014 was of 300 million tons. 40% by weight of world production takes place in Asia. China on its own produces 25% of the world production. North America and Europe cover each 20%. The annual volume of globally traded waste plastics is around 15 million tons, less than 5% of the new plastic production. This shows that recycling of post-consumer plastic waste is still in its infancy. Is it better to burn plastics or to recycle plastics? Depending on the plastic type, the production of plastic containing 1 unit of energy as materials can take approximately 1.8 units of energy to produce. Therefore, the environmental benefits of incineration of plastic in global terms should be questioned. Here again we have one table comparing the environmental impacts of producing 1 ton of high-density polyethylene granulates, both from virgin materials and from recycled materials. Except for solid residues, which are increased considerably, the production using recycled materials reduces all the other environmental parameters measured here in very big amounts. This concludes that recycling plastics has in general more environmental benefits than non-recycling plastic. Our last fraction for this module is metal waste. Iron and aluminum are the main metals found in waste. They are produced from mineral ore and used for a range of products, some having very short lifetimes, such as packaging of cans, foils, and containers, and others having very long lifetimes, such as materials in buildings and construction. The types of steel and aluminum that are being recycled are metal scrap, originated in industries, constructions and demolition, end-of-life vehicles, and post-consumer waste, mainly packaging. This last fraction is the least attractive because it is very mixed and not clean. The recycling process of metal involves several steps. The very first is cleaning the material. This might involve the tinning, the coating, and the oiling. Once the material is cleaned and sorted, this is introduced in the furnace and is smelted again. In this video we see how operators in Bangkok introduce metal scrap in the furnace. The smelted metal is then used to generate new products. It is interesting to point out that a clean metal scrap can be recycled without loss of quality. Recycling of post-consumer metals has a long history. More than a third of all the aluminium, as well as of all the steel currently produced globally, originates from old, traded and new scrap. The trading market of scrap is global, but it's again concentrated mainly in Asia. Approximately 50% of all the recycling plants existing in the world are located in the Asian continent. 17% are located in Europe and 20% are located in North America. What about the environmental impacts of metal recycling? The virgin materials for steel and aluminum production are limited and are not easily accessible and have high energy costs. Remelting the scrap saves a lot of energy, making room even for long-distance bulk transportation around the world for its recycling. Once more, here we see the comparative table of producing steel from virgin materials and recycled materials. We see that in this case, except for the amounts of scrap consumed, which obviously increase for the productions based on recycled materials, all the other parameters again will reduce considerably, both emissions and input materials. This means that obviously recycling steel has more environmental benefits than producing it from virgin materials. Now that we saw how materials are recycled, let's have a look to the recycling rates of 39 different cities around the world. This data covers both dry recyclables and organics, and where possible, rejected amounts were corrected. The figure shows no clear relationship between recycling rates and income levels. Indeed, the highest recycling rates are achieved in high-income countries. But many middle and low-income countries also achieve high recycling rates. This is the end of the module. In this module, we learned recycling of municipal waste. We mainly focused the module on 4 very common waste fractions. Those are paper, glass, plastic, and metals. We covered some production data. We also saw the recycling process of each waste fraction. We saw some interesting global facts about each one, and we also mentioned some important environmental aspects. For those interested in getting more information about the topic, we recommend to consult the following key readings. Much of the information used on this module was also taken from here.